In this lecture, we're going to discuss and learn about metals. Now, metals, as I've previously shown you the periodic table, they are on the left-hand side of the periodic table, on the left-hand side of the staircase that we drew earlier. They're all metals. Now, there are different types of metals. There are group 1, group 2, group 3 metals. Then you have transition metals. Now, the first thing that we need to discuss when we are studying metals is we need to describe the structure of a metal. Now, the structure of a metal is described as they form a giant metallic lattice in which you have positive metal ions, you have positive ions are present in a sea of free moving or delocalized electrons. So metals form a giant metallic lattice, and the structure has positive ions, which are surrounded by a sea of free-moving delocalized electrons. The way we're going to discuss, let's think of sodium metal. Now, sodium is in group 1. It has 11 electrons, and the atomic mass is 23. That means it has 11 electrons. So the electronic configuration is 2, 8, and 1. It has one valence electron. Now, to complete its to have a stable electronic configuration, it needs to lose one electron. When sodium loses one electron, when it loses one electron, it would become Na plus 1. But when you have a metal, that metal, there would be other metal ions and they would all be losing one electron. So those electrons have no place to go. If there were a non-metal present, then that non-metal would have gained that electron. But since that one electron that is lost has no place to go, it's going to roam around freely and it will become delocalized. So you're going to have, the structure would look like this. You're going to have positive plus 1 sodium ions, and they would be arranged in a regular lattice. So you have all these plus 1 ions. So you have all these plus 1 ions, and there would be electrons lost. So I'm going to draw those electrons in red. There would be electrons roaming around freely. Each one has lost one electron. So you have all these electrons in between roaming freely. So you have positive ions and a sea of free-moving delocalized electrons. Now, metallic bonding is a relatively strong bonding. If you from your everyday experiences, you can see that iron is a strong metal. Steel is a form of a metal. You have other metals. Aluminium is a good metal. So by looking at the structure, you're going to see that they are hard structures, and it is a strong bonding. The reason why metallic bonding is strong is that this electron is negatively charged. It's going to attract the positive ions around it. Similarly, this electron is negatively charged. It's going to attract the positive ions around it. Opposite charges attract. This positive ion is going to attract electrons around it. Similarly, so these electrons basically act as a glue between positive ions, which is why it's a very strong type of bonding. Similarly, we can be asked to draw the structure of a metal of another metal. Let's say we're asked to draw the structure of magnesium, which is 12 and 24. It's in group 2. The electronic configuration, there's 2 electrons in the first shell, 8 in the second, and there are 2 electrons in the last shell. To get a stable electronic configuration, it loses 2 electrons. When something loses 2 electrons, it is going to form +2 ion. So for magnesium's case, instead of +1 ion as shown in the previous one where we were dealing with the sodium, magnesium would be +2. There will be +2 ions. So you have all these +2 ions, and there would be 2 electrons delocalized, lost by each of the ions. So those 2 electrons would be delocalized. So you have all these 2 electrons. Each one is giving off 2 electrons. So this would be the structure of magnesium atom. The only difference is instead of the 1 electron being delocalized, the 2 electrons being delocalized, being contributed by each of the magnesium atom. You're going to write +2 ions instead of +1 ions. So you need to make sure that you're doing this correctly. If you're asked to draw a structure of any metal and they haven't specifically named which metal that you need to draw the structure of, then you can simply draw this diagram and that would be sufficient. And remember to draw at least 12 atoms, 12 ions. That would be sufficient. That would be the minimum requirement that Cambridge is going to ask from you. Another thing that you need to remember is, remember that the positive ions in this structure in solid state are stuck in position. They cannot move. Only the electrons are delocalized and only they are free moving. Now we're going to discuss the properties of metals based on the structure. The first property is that metals have high melting / boiling points. Now metals have high melting boiling points. This is due to the strong metallic bonding. So metallic bonding is strong. There's one exception to this. Most metals have high melting and boiling points, except Hg, which is mercury. Mercury, if you're familiar with mercury, which is present in the bulbs of different thermometers, it's a liquid. And the reasons for that are very complex, but mercury is a liquid. Other metals are solids and they have high melting and boiling points. The second point that we're going to study is that metals conduct electricity. Metals conduct electricity, and the reason for that is they have free moving delocalized electrons. So they have free moving charges and those charges can move around, which is why it can conduct electricity. Remember, the positive ions are stuck in position. They're not involved in electricity conduction. Only the free moving delocalized electrons are the ones that are conducting electricity. The third point is that metals are insoluble in water. You wouldn't see metals dissolving in water. They would react with water, but they will not dissolve in water. The fourth point that we're going to study is that metals are malleable and they are ductile. What that means is malleable means that they can be reshaped. What ductile means is they can be drawn into wires. Previously, we studied ionic compounds, and they were brittle structures. You can't reshape them. They can't be drawn into wires. Metals are probably apart from plastics and organic polymers. These are the only ones that can be reshaped and drawn into wires. The reason for that is that when a force is applied, the metal ions can slip and slide. Metal ions in the giant metallic lattice can slip and slide over each other. So metal ions can slip and slide over each other. I'll show you the diagram again. What we mean by applying a force is when a force is applied, let's say for example there's a force being applied from this side. So when a force is applied, these metal ions can move and slip and slide over each other. This can actually take squeeze in between this one. So when a force is applied, they can slip and slide over each other, which is why they can be reshaped and they can be drawn into wires. The fifth point is that metals are also very good conductors of heat. Good conductors of heat, and again, the reason why they are good conductors of heat is that they have free moving, delocalized electrons. When heat is conducted in a solid, what happens is that this particle gains energy and it would start vibrating very quickly, and those vibrations are going to be transferred to this particle which is right next to it, and this would start vibrating very quickly again, and then this would transfer energy to this particle by collision, and it would start vibrating, and so heat is transferred across a solid structure. But metals have an additional particle, which are electrons, which are free moving. What happens is if you heat this end of a metal, these electrons will quickly gain energy, and since they are free moving, they can quickly go to the other side. When they go to the other side, they quickly transfer that heat to that other side. So due to free moving electrons, metals can conduct electricity very, very quickly. We will now discuss alloys. And alloys they are a mixture of metals. For example, you have bronze, which is an alloy, or it's a mixture of metal with an impurity. And that impurity could be a non-metal as well. So steel is one in which you have iron and carbon is mixed with it. Now, alloys are very commonly used. Most metals that you find in everyday life, they are alloys. The property of alloys is that they are Alloys are stronger and they are less malleable and ductile compared to metals. Pure metals are soft. For example, jewelry is not made from pure gold. There are impurities added to pure gold to make it stronger and less malleable and ductile. Similarly, cars, etc., are not made from pure iron. They are made from steel. Steel is a stronger substance. So alloys have this property that they are stronger. The first thing that we're going to study is we're going to discuss the structure of an alloy. Now, the structure of an alloy is very similar to that of metal. For example, we have copper and zinc, and they are forming an alloy. Now, when copper and zinc mix together, the structure is still going to be it's going to be a giant metallic lattice, but there's one difference. The difference, the small, tiny difference that occurs is that they have different sized atoms. Zinc is a bigger atom compared to copper. So you're going to have, let's say copper is forming a +2 ion, you're going to have a +2 ion which will represent copper. Then there would be a zinc atom that would also be a +2 ion, except the difference now is that the structure is, the sizes of atoms are different now. Similarly, you're going to have another copper which is going to be +2. There would be another copper +2. There could be another zinc ion that's +2. This is zinc again. Then you can have a +2 copper, another copper, then another zinc, now this is the structure of an alloy, and it's going to have delocalized electrons. There will be plenty of delocalized electrons. In between, and each one is going to have two delocalized. Each atom, copper also forms +2 ions, zinc also forms +2 ions. So both of them are going to end up losing 2 electrons. Now this is the structure of an alloy, and slightly different that you have different sized atoms in the structure of an alloy. Now what that does is, different size atoms, it makes the structure stronger and it makes it less malleable and ductile. The reason is that the reason why it's less malleable and less ductile, and why it is stronger, is that when a force is applied, for example, I'm applying a force from this direction. Now it's an irregular lattice. So it's an irregular lattice. So due to different sized atoms or ions, the layers can no longer slip and slide over each other. Layers of metal ions can no longer slip and slide over each other. So you can see that, for example, you had this +2. Now it's not a layered structure, it's an irregular structure due to the different sized atoms, so they can no longer slip and slide over each other.